In this tutorial, we will be discussing how to balance a nuclear reaction. So when you're balancing nuclear equations, the biggest thing to remember is that the top number and the bottom number have to be the same. What I'm referring to is the mass number and the atomic number. So as things enter and leave the atom, these have to balance out as if this arrow was an equal sign. So that's why I have an equal sign up here. So 247 plus 4 is equal to 251, which is what we started with. 96 plus 2 is equal to 98, which is what the bottom number was. So think of the arrow as an equal sign. Terminology is super important when it comes to nuclear equations. Things like emits, decays, gives off, things along those lines, that means it's going to be on the right hand side of the equals of that arrow. Absorbs, things along those lines would mean it's going to be on the left. So for instance here, we have an alpha particle that's being released. It emits an alpha particle, which means it's going to be on the right hand side. So 234 plus 4 is equal to that starting number of 238. 90 plus 2 equals 92, which was the starting number of uranium. So let's go through a few of these practice problems. So here we have americium of 241. It's emitting an alpha particle, hence the word emission there. So 241 is equal to something plus 4. So that top number then is going to be 237, because 241 minus 4 is equal to 237. Now the bottom number, we start off with 95, is equal to, because that's where the arrow is, something plus 2, because that's the bottom number of helium, of the alpha particle. So 95 minus 2 comes out to be 93. And that's going to be our bottom number. So it's going to be 237 over 93. Now to figure out what letters to put there, what symbol to put there, we're going to look for the bottom number, so 93. That's Neptunium, NP. Beta decay, done almost identical. Once again, emitted. 0 over negative 1 is going to be the symbol you're looking for. So that's why that's there. It's written into the equation just like that. And so just like before, this arrow becomes an equal sign. And you add it in just like it was an algebra equation. Let's try one of those. So K is potassium, it's 42 on the top. That's what that means, so that's the mass number. We need to figure out what the atomic number is. So in order to do that, we need to look on the periodic table. You look for the letter K, and we find out that it's 19. Notice it's always the atomic number on the bottom. That's the number of protons. It's decay. It's emitting it, which means it's going to be on the right hand side. So 0 over negative 1, E, plus whatever we have left over. So 42 is equal to 0 plus X. That means our top number is going to be 42. 19 is equal to negative 1 plus X, which gives us the number 20. So 20 is what we're going to look for on the periodic table. It's right there. That's why we have calcium. Beta decay of cobalt. So CO, 60 is the top number. To find the bottom number, we look at the periodic table. 27. It's decay. It's an emission, so we're going to put it on the right-hand side. 0 over negative 1, E. So 60 is equal to 0 plus 60. So that number didn't change. The bottom number, 27, is equal to negative 1 plus x. That comes out to be 28. 27 is equal to negative 1 plus x. So we add 1 to both sides, and that's how we got 28 here. So 60 over 28, 28 is nickel. And so that's your answer, 60 over 28 Ni. Positrons, 0 over positive 1. You do it the exact same way. Remember to read the terminology very clearly. That's the part that always gets people. Gamma, notice that there's no number changes with gamma. It's 0 over 0. All it is energy. So transmutation is when you actually bombard atoms together. So you're actually making a bigger one rather than a smaller one here. But the process is still the same. So we have nickel, 58, which is on the top left-hand side. Nickel is 28, so it's going to be on the bottom. Bombard nickel with a proton of 1 over 1 H. A radioactive isotope and alpha. So we have 58 plus 1 is equal to 4 plus x. So 59 is equal to 4 plus x. That's going to equal 55. The bottom number, 28 plus 1, is equal to 2 plus x. So that's 29 is equal to 2 plus x, which is then equal to 27. So we look on the periodic table, 27 is cobalt. Go through these processes as if it's an algebra question. We're going to end up with one more. 98 plus 1 is equal to something plus 4. So that's 99 minus 4. That comes out to be 95. The bottom number, 43 plus 0, is equal to x plus 2. That comes out to be 41. So we look on the periodic table for 41, and it's NB. And that's how you do nuclear reactions.